Hello friends, welcome to Risingpearl.com. Today we are talking about series 5 where we are learning about polynomials. This is our episode number 3, and friends, today we are going to learn about zero of a polynomial. Now this is something that we have already learned in our earlier grades, but we are going to take a quick look at what we mean by zero of a polynomial. Now if you recall friends, zero of a polynomial means we say that zero of a polynomial px is a number k such that pk, that means the value of the entire polynomial px at k. In the last episode we looked at how do we find out value of a polynomial. So we say zero of a polynomial is a number k such that pk equals 0. That is, the value of the polynomial px at x equal to k is 0. So in the last episode we looked at different values of the variable you can get different values of the polynomial. So if there is a value k such that the value of the polynomial at k is 0, if that happens, then we say that that particular number k is the 0 of the polynomial px. So like we always do, let's take a look at some examples. It will help us better understand this. So let's first write a polynomial. So let's say we do something like 5x minus 12. If this is a polynomial, and of course this is a polynomial, so we write the polynomial as px like this. I kind of wrote it reverse, but px is equal to this. I think you get the point. So now what we want is we want to find out the value or the 0 of this polynomial. So how do we do that? So let's say at some value of x, this polynomial becomes 0. That means at x equal to k, the value of polynomial at k becomes 0. Then k will be the 0 of this polynomial px. So now at k, what will be the value of the polynomial? So in the last episode we saw how to find value of a polynomial at a particular value of the variable. So we have, let's write it here. So we have px is given as, I have again randomly written these polynomials. So here 5x minus 12. So if this is my polynomial, what will be the value of this polynomial at x equal to k? We will simply replace x by k. So it will be 5 times k minus 12. Now in order for k to be the 0 of the polynomial px, this value must be equal to 0. That is by definition. So this value should be equal to 0. And then solving this equation will give us the value of k. So from here we see that 5k is equal to 12. We simply took the minus 12 on the other side of the equation, the equality sign, or k is equal to 12 divided by 5. So in other words, at this value 12 divided by 5, this polynomial becomes 0. And so we say that this is the 0 of this polynomial px. And you can quickly check this yourself. So simply, if you say what is the value of this polynomial at 12 by 5, just the same way that you can check the value of this polynomial at p1 or at p2 or any other value of the variable, you can find out the value of the polynomial. So at 12 by 5, the value of this polynomial will be 5 times 12 by 5 minus 12. That is the polynomial 5x minus 12. So simply instead of x we have put 12 by 5. So if you look at this, so 5 and 5 will cancel out. So you will have 12 minus 12, and there you have it, 0. That means at 12 by 5, the value of the polynomial itself becomes 0. So we say that this 12 by 5 is the 0 of this polynomial. Let's take a look at one more example. So let's write ourselves one more linear polynomial. So how about we say 3x plus say 15. So our polynomial px is 3x plus 15. Now, so what is the 0 of this polynomial? How do we find the 0 of this polynomial? So we are again going to assume that let's say k is the 0 of this polynomial. That means then from here it follows, actually let's just cross this out. So the value of the polynomial at k will be equal to 0, right? That is from the definition. So what is the value of this polynomial at x equal to k? So that will be pk. So wherever we have x, we are going to replace that by k plus 15, and at polynomial at x equal to k, they should be equal to 0. So solving this equation, we can find out that 3k is minus 15, plus 15 goes to the other side of the equality sign. Dividing both sides by 3, we get k equal to minus 15 by 3 or minus 5. 3 and 5 cancels out, minus 5. And again, we can simply check if our answer is correct. So p minus 5, that is the value of the polynomial at x equal to minus 5, will be 3 times x plus 15, or 3 times x, instead of x we will put minus 5, plus 15, minus 15 plus 15, and that will be equal to 0. So again, the value of the variable for which the value of the polynomial becomes 0, that particular value of the variable is called the 0 of the polynomial. So in this case, minus 5 is the 0 of this polynomial, because at x equal to minus 5, this polynomial becomes 0. So friends, I hope that you are also able to appreciate that the 0 of a polynomial is very different from the value of the polynomial at x equal to 0. So in this example, if I had to find out p0, that is, what is the value of the polynomial at x equal to 0. So to do that, we will simply put x equal to 0. So this will become 3 times 0 plus 15. Now 3 zeros are 0, so answer is 15. Meaning that at x equal to 0, value of the polynomial is 15. This is very different from the 0 of the polynomial. 0 of the polynomial again is such a value at which the value of the entire polynomial becomes 0. So friends, here as you can see, we have been really focusing on linear polynomials and trying to find out the 0 of a linear polynomial. There is a specific reason behind that, and I'll get to that in just a moment. So now, generally speaking, the way we write a linear equation or linear polynomial is ax plus b, where a and b are real numbers. And the reason we write it in this way is that we know for a polynomial to be a linear polynomial, there must be only one variable term, and the value of that should be raised to 1. And so here a is a real number and b is a real number. So b is the constant term, and there is one other term that has a variable and x is raised to 1. So this is a standard form of a linear polynomial. So if we have to find out the 0 of a linear polynomial, so what we do is that, so we say, so our polynomial is px, which is equal to ax plus b. So simply by equating this to 0, we find out that ax equal to minus b, or x is equal to minus b divided by a. That is, dividing both sides by a, we get this value. That means for x equal to minus b by a, polynomial px will be 0. So this is the standard form of any linear polynomial, and this is how, and this is going to be the 0 of the linear polynomial, minus b by a. If polynomial is ax plus b, then the 0 of the polynomial will be minus b by a. So the reason, friends, we have been focusing only on linear polynomial in this webisode is that there is a significance of linear polynomial versus quadratic polynomial versus cubic polynomials. So over the next few webisodes, we are going to take a look at each one of these polynomials and understand what does the polynomial actually mean from a geometrical standpoint, and in that context we will try to find out what is the meaning of 0 of a polynomial.